we will allow you to join as a panelist briefly and speak with video and audio, and everyone will be able to see you and hear your question. If you'd rather not be seen, you can keep your video off for that. And if you'd rather just ask your question, there's the Q&A box down at the bottom. And just a quick disclaimer for everyone, we are recording this webinar for to share.
Oh, continue. Okay, there's my
and just a quick note on safety. As kind of using Zoom, and it's come out over the last couple months, Zoom bombing and Zoom hacking has been a bit of an issue. So we've taken a bunch of steps to prevent that. As you can see with the webinar, attendees are all, no one can talk and we can't see anyone. And prior to this, we had everyone register, which I actually went through everyone and checked to make sure that everyone was who we sent invitations to and was someone that we wanted in the webinar. So everyone's been approved personally by me. And if somehow someone were to get a panelist login, we can, if we see someone that we don't know, they will be removed from the call.
Great, thank you so much, Eli. I've just promoted Elliot to panelist because I believe that he is going to guide us through the next stage of a prayer.
As long as you didn't demote me, Laura.
Well, that might come next, depending on how you do. Elliot is our, works with the Resilience Institute, is the Indigenous Community Liaison, and especially this is his main project, the Fire with Fire initiative. And Elliot Sabrain is working with all 4 communities to ensure that we start our webinars in a good way. So with that, I'll turn it over to Elliot, and then after prayer, I will start with an overview of the agenda.
Okay, good morning. Thank you, Laura. Yeah, good morning. Okay, Stuanok, Goyo Gini. So I just said hello in Blackfoot language. I said my Blackfoot name, which translates to wolf caller. And I said, I'm glad to see everybody today. So I just want to say hi to David and Shawn. I met David a few years ago, and I haven't met Shawn until now, virtually. But nice to meet you, and thank you for participating in our webinar. Yeah, my name's Elliot Fox. I'm currently the Indigenous Communities Liaison for Fire with Fire. I'm from the Kainai First Nation and Blood Tribe, and we're part of the Blackfoot Confederacy. I've got an elder from our community. I got an elder yesterday, so our elder today is different, and our elder today is my mother. So I'm gonna turn the screen to my mom, and she can say a few things, and she'll offer us a traditional Blackfoot prayer. Okay, Mom, here you go.
Okay, get a connection, Matsin Poa. Nistoana go ni pomat. Nichikaina. And Nichikutaxi that. Not going to Greetings to all. I'm Georgette Fox, the mother of Elliot Fox. I'm really quite honored to have been asked to say the prayer for you today. I was a member of the Buffalo Women's Society for the Reserve for a number of years, and so I guess that qualifies me to say prayers for groups and for people.
Yeah, so just sorry to interrupt, Mom. just for our group here today. Yeah, so my mom worked many years as a student counselor with our college, our local college. So she's retired, but she's keeps busy because they utilize her as an elder for a lot of functions. So anyway, okay, go ahead, Mom.
Yes, okay. I will now say a prayer for all of us. And I'll pray in my language, my first language. Ayo, it's bad. Yayo sako Christian, Kiaka Kitan, Christico, Ikinoka, Katsumat, Ayo Nox Pomos, Okuan, Chekokas, Takat, Ayo Nox Pomu Kitakitoman, Nitsi Oxis, Ayo Nox Pomos, Okoakaitam, Okita Pessimi, Opitam, Kyoko, Sexakaitam, Otatsimi. Ayo kenokam kuta putaksini akukana soka piani uchitapoa kahpi. Ayo speta pio. Ayo nox pomos nichinamin nonixi kenix mahkoto steaks. Ayo nitotuma kinanya iksi kota putaksuai. Ayo speta pio nox pomo kita nokamo nite puatu pi nokoa matatu tsikato matopoka putakimi amux makokitsuka bisi anoksakui nitastotsi pi. Ayo amuskaki nokaka manistich speta pio na pio sinin tawatsimani kimapi pitsin. Thank you.
Hey. Okay, so thank you, Mom, and yeah, so that's our prayer, and she just prayed for us to have a good meeting, that she's very glad to be asked and very honored, and she prayed for our families and that we'll be safe and we'll have a good webinar today. So thank you, Mother.
Thank you so much, Elder Fox. That was always good to start our meetings in a good way. And with that, I'm going to get going because we have a lot to cover today, and I don't want to spend too much time with you listening to me because we have two really great scientists here. They are both so modest, so I have to tell you all about them because they won't. But Shawn Marshall is currently, he is the science advisor for Environment and Climate Change Canada and living in Ottawa. He was mostly out here. He spent most of his time, I guess, as an adult working at as a professor at the University of Calgary. He's a renowned glaciologist, climatologist, and a really wonderful person to work with. And we're so fortunate he's also our board chair. And then following Shawn is Dave Sauchyn, who is the director of the Prairie Adaptation Research Collaborative, but does many, many other things. He has extensive research into climate change and tree rings, and I mean, that would be an entirely different webinar, but the linking of looking at the past through tree rings and climate change, and also some of the work he's done with Indigenous communities is really quite interesting. So I hope that our journey with both Dave and Shawn continues, our learning journey. Okay, getting into this, today's agenda is pretty simple. Opening prayer. I'm going to do a quick background on our Fire with Fire initiative, just for those of you who have joined into the initiative a little bit later, and a reminder for some of us as this initiative has been going on for some time. And then Shawn Marshall will, and then I'm going to do a little quick overview of climate change, just really the basics, just to create a foundation. And then Shawn will talk about climate change science in more detail, and then Alberta's past, present, and projected change will be presented by Dave. for your questions and answers, I do note it at the end, but I think if you have questions specific to Shawn or Dave, you could ask right after they're speaking, either, as Eli said, either in the chat room or raise your hand, and then you're welcome to speak. We just have to code it so that then you can also be present with us virtually. Okay, a little bit about us, and this will all be on your Facebook page as one of the resources, so I'm not going to go into this in too much detail, but we are a charity. We work close with communities and we develop initiatives with those communities. And some of the things we do are local early action plans. We use creative approaches for engaging communities. So some of those have been the art of climate change, stories of resilience, and we've developed some climate change games with a few communities. And every community is different, but the idea is that we're doing some local early action planning plus the implementation of adaptation strategies, while also finding ways to engage communities in this big conversation in positive and interesting ways. Fire with Fire, this first part, we're working with 4 First Nation communities across Alberta. And the idea is that we want to bring together the best that we can find, scientific and Indigenous knowledge and perceptions, values about fire, so that eventually it will inform practices for local, regional, provincial communities. Because fire is a big thing, big theme. So we wanted to look at how can we grow our capacity to adapt by looking at this theme. It's not just about management, it's also how we perceive one of these elements. The initiative includes participatory video trainings. This is a method for collecting information in communities. So we're doing that. That's largely, that side of it's handled by our partners in the Alberta government. And then knowledge sharing on climate change and adaptation, like we're doing today, but also woven through the entire initiative. Community screenings on new fire-focused videos. So one of the outcomes of the training is some videos where people can practice also their skills, but then have the community really involved. So what does participatory really mean? And we've been taking some training recently with Insight Share on that, and I think our ideas are becoming much more broad. And then summary reports. So what is this all good if it doesn't get into the hands of people can actually make informed decision making going forward? So we are committed to reports and videos and ways of getting this out there, whether it's to communities to do their practices in new ways, or if it's maybe helping the people who manage fires at the provincial or the national level start thinking about fire differently and working with communities differently. So here's a little map of our partner communities. We're way up here, and then we're down here. It's kind of neat. And then in the central here, the Blood Tribe, Bagani, Samson Cree, and Denny Da. And why are we doing this work? Well, increased fire frequency, scale, intensity. They're having significant impacts already. And this is only supposed to get worse. So we want to understand, I already said some of this, and that really hinges on having the best possible knowledge. And where does that knowledge lie? I don't think it's just in textbooks. So we want to work with communities and understand more about fire. And this I really like. This is one, Sam Hester, who's a graphic artist that's been along our journey. This came out from one of our first, when we were able to gather in person. We had our first workshop together, and she did a really nice little, well, it's actually quite big. It's a big mural of all the work that we were doing. Okay, but we're also doing this work because it's about understanding one component, at least one threat of adaptation. We already, I think you know that scientists from all over the world agree that climate is warming at unequivocal rates, and the observed changes are unprecedented. Most are saying this is not just climate change, this is a climate emergency. Ecosystems are already changing, and it's making adaptation to new climate scenarios challenging. And this is going to be even more complicated now because we're in a pandemic and we don't know how long we'll be in a pandemic. So partnering to weave knowledges can fast track. If we only took a scientific approach, we'll probably not get to the transformative ways. But if we only took an Indigenous perspective, maybe we wouldn't have the science that might help. So by bringing knowledges together, we might be able to fast track some of the adaptation strategies. And maybe on a positive note, this is really an extraordinary time to be living in the world. There's shifts happening, and maybe we can be part of the shift in thinking for a more holistic and interconnected way of being. That gets me up every day and keeps me positive. So climate change ahead, the basics. This, you will find elaborate definitions of mitigation, adaptation, and climate resilience. I've tried to pare them down so they're really simple, because if your mom or your little brother or somebody asks you, like, what does that mean? And you give them the definition that the UN puts out, you're going to lose them at the first two words. So I figured the best way to think about this is mitigation is the efforts to prevent future emissions of greenhouse gases. Adaptation is about a process of adjusting to what's happening now, or we can anticipate. And this is where our focus really lies of this work. It's about adaptation. And here's just a few examples of what adaptation could be. And I included renewable energy because even though it's often talked about as being aligned with emissions reduction, renewable energy is also a way of preparing for the future and energy security. So this, Shawn will explain, one of them will explain more, but I really like this because it helped me understand simply using a bathtub. If you fill up a bathtub and you want it to drain, your drain has to be large enough for whatever's in there. Otherwise, it's going to start to overflow. And that's kind of what we're doing here. So the faucet is putting way more than the world, which is the drain, the carbon, the natural carbon sinks, like the oceans, of trees, the Amazon, can do its work with the carbon. So I really like this way of understanding, or just put too much up there and natural cycles aren't working anymore. So climate change, any long term in the Earth's surface. So when you hear things like, well, we're trying to get to 1.5 degree or we're going up, like, doesn't seem like very much, but on a global scale, 1 degree has massive consequences. Global warming, of course, that's the whole Earth, and weather is what we see. So this is the minute to minute changes. So that could be, so how does climate change, for example, impact weather? Well, you could be having bigger events, longer events, maybe hotter days for a longer period of time, less snow. Expected impacts in a nutshell: Earth warmer. That might be good for some people. You might be able to grow more vegetables in some places, but it's going to overall bring some challenging times. More evaporation means more precipitation. So you might see you might see your whole rainfall happen in a day or over a week. It really gets varied. So even though there's areas that will have drought, they also might have floods because they're going to get rain, but it's rain where the Earth and the systems can't handle, and make mega weather events more frequent and more often. And this, I encourage you to have a look at this after, if you haven't already seen this, because I think it's a pretty good way of showing just all of the different ways that climate change can have an impact on our world. Like anything you can imagine, the warming world and all that comes with it, these can be consequences. And it helps us to think when we're doing adaptation planning, all the different areas of life where we need to, oh yeah, like how's that gonna how's that going to be with our food? Or what about waterborne diseases and allergies? And allergies came up with one of our communities a lot, seeing a lot more allergies because of the air qualities, and also invasive plant species that have been coming in. So just some points to consider that I like to leave people with is that even though we can plan today for what we know, flexibility is really important in your planning because circumstances can change. And you may have heard of things like tipping points. And this is where things can change in a way that will significantly change other things in the environment, and also with movement of people and animals. So even though we plan now, we might put a really good 5-year plan together, we may have to revisit that. And planning to replan is important. And as mentioned, it does really exacerbate all other challenges. So for communities that are dealing with substance abuse and housing issues and other things that are unresolved, now add on top of that much hotter days or changes in weather, it just really can exacerbate other challenges, which is why it's so important that communities start taking climate change and planning seriously. It's happening faster than most living systems can naturally adapt. It's not just humans, it's animals too. And relying on past cycles to inform tomorrow, we can't just rely on past cycles because things are changing. We have to revisit this. And changes to the environment impact culture, which is really important, I think, for First Nations communities, because if you can't find your traditional plants anymore, it's going to be really hard to practice those same practices. And weaving, braiding, we use that interchangeably. We actually use whatever term the community we're working with at the time is most comfortable with, but it can help fast track to these complex challenges. And then you'll see, so this will all be on your resources. This is just a whole bunch of different links that you can have a look at that may resonate with you. I find some of them are pretty good, and a few books you might want to consider if you want more information. And with that, I am going to pass it over to Shawn Marshall.
Thank you, Laura. Any questions from people for Laura while I queue up here?
They've probably heard lots of me, so they're like, okay, we're tired of listening to her, get on with it.
Showing the presentation.
Yep, now you just need to make it so it's
Good.
full screen.
Thank you. Yeah, you would think that with online teaching, I would be really good at this by now, but I'm still always fighting technology a bit to get to the top. That's a quick preview in backwards here. Okay, thank you. And thank you to everyone for joining us, and Laura for the great introduction. And I've got a few slides, and I think it's an introduction which might be a little bit basic for many of you because you might know some of this, but I want to just have us all on the same page together in this kind of introduction to this huge, huge topic. And I think all of us at the Resilience Institute and on the call today will be really happy for follow-up with questions. And Laura's already given you lots of really great resources here. So I don't know if it was Laura and Eli that dubbed this keeping the fire burning, but that's like, it's a bit of a scary notion when we're thinking about global climate change, because we just think of how the world is on fire a little bit, and all the graphs we've seen, and I'm sure everyone has seen these kinds of pictures of what climate change looks like globally. It's maps that are full of red like this of places that are warming, and there are not many places in the world that are warming as much as Canada and the Arctic. We've got rates of warming 2 to 3 times more than the global average, and for very systematic reasons that are expected to continue. So climate change is very, very real in Canada and for I'm sure all of your communities. So I'm going to give just a really quick introduction to what I would, I guess, call the modern scientific understanding of climate change and what's driving it, what's pushing our climate around. I'll say a little bit about the international climate policy aspirations and where we hope to stabilize the planet somehow, and then a little bit about where it looks like we're headed, and then pass off to Dave that will look in a lot more detail of where we may be headed locally and regionally. So you've, again, probably seen pictures like this before. This is a construction of global temperatures, global average temperatures from 1880 to present. It's 2020 is not completed yet, but we're on course to be the second warmest year on record after 2016. And so you'll see in the red bars, the last 4 decades now are all above normal in a way. They're all warmer than the average 20th century temperatures. So what we're living in now is what's called global warming. It's this world that's warmer than the world that many of us were born in or maybe grew up in. And for some of you, the younger ones in the call, you've never known a world with blue bars. You've just always known this ever-warming world that's above the baseline and in the red here. And I guess the big challenge is that it's not like we're stabilizing at some warmer temperature. It's going and going for reasons I'll talk about a little bit, and we're not sure where it's going to stop. And that's a great concern for our ecosystems, for human health. Laura gave all these, important reasons, not just, something that's very hidden in this idea that the world is warmed by 1 degree. It means a great amount for severe weather and health and biodiversity and all these things that we care about: water security, food security. I'm going to share just, again, the kind of scientific way of knowing on this. And I appreciate that, especially for many people, most of you on the call, there are lots of other ways of knowing. And when I talk to elders or farmers or anyone that lives on the land, I get great insights about what's happening and what's not normal and how things are changing. And I think what Western science has to offer maybe is that it has ways to measure things in a systematic way so that you can calculate something like global average temperature. And you can go to the atmosphere and go to the oceans and go to these complicated weather and climate models and try to say something about what's happening to the whole planet. And I think there's a lot of strength in what Laura said, is if we can bring together local and regional stories and understanding of what it really means on the ground with this bigger picture that you can see from satellites and from these huge global observing networks. And what you see is what's shown here. It's the same data, but if you look at decades, 10-year average temperatures, you can see the path we're on in these past 40 years and how it just keeps going. And 2020 is off to a start to set another decade that's going to push us off the graph to the right here. And I do want to say this isn't something that's new. It's not something that we only are just understanding. This is an article from New York Times in 1956, before we had a lot of these observations, actually. Which basically states, where we are right now. Warmer climate due to more carbon dioxide in the air. And you'll see if you read this, which I won't leave up long enough, or you may not be able to see this too well, but they talk about burning coal, oil, and wood. You can see the little subtitle down there, generated by man. Like, this was very clear more than 60 years ago what's happening. And partly in response to this understanding in the 1950s, a pretty visionary scientist in San Diego at Scripps Institute for Oceanography named Charles Keeling went to Hawaii to a big volcano called Mauna Loa and set up these measurements of carbon dioxide in the atmosphere, which were the first time we were actually able to measure actually how much CO2 was in the air. And so Laura gave us nicely this bathtub picture of greenhouse gases, and CO2 is the most, carbon dioxide is the strongest or the most abundant of those greenhouse gases. It has the strongest effect on our climate right now. And it was postulated, it was thought that human activity might be causing CO2 to build up in the atmosphere, but we didn't know that for sure. I wasn't around. Scientists didn't know that for sure in the 1940s, 1950s, because they didn't have measurements of carbon dioxide in the atmosphere. So it's possible, some people argue, that maybe natural sinks in the ocean and in the trees were able to pull out all the CO2 that we were putting into the atmosphere by burning coal and oil and gas. So Keeling started these measurements, and you've seen this kind of curve in data. This is what it looks like. Those were started in 1958. They're continuing to today. And you can see the buildup of carbon dioxide in the atmosphere through this time, with a increase through the years, rising and rising. We're now over 400 parts per million. I just double checked where we're at. As of last September, we were at a little over 408. And as of today, we're at, or 2 days ago, we're at 413 parts per million. So it's been going up by 3, 4, or 5 parts per million per year. Even COVID-19 confinement has not put much of a dent in this, because a lot of this is really very structural. It's our heating and energy systems and air conditioning, a lot of things that haven't changed, even if air travel has gone down this year. It's a very huge challenge for the planet to stabilize or change the inflection of this curve. And so CO2 is one of the main gases in the greenhouse effect, which acts to trap Earth's radiation and hold that heat in the lower atmosphere. And then that just keeps, like a greenhouse, it keeps the world warmer at surface level. And that's been understood for over a century. It's a pretty well documented and almost easy. It's almost the easiest part of climate change, I think, to understand how greenhouse gases like CO2 make the world warmer. But it's also clear that other things can push the climate around, like the sun and solar variability and other things like land use change. And so climate scientists have been looking at these things and are monitoring these things also very carefully. But if you look at, for instance, the sun, despite the kind of billboards you might see outside of Calgary sometime, it's very clear that solar activity is not responsible for climate change in the past many decades. This is just showing direct measurements of the sun from the past 40 years or so, and it has these 11-year sunspot cycles, but it's not something that's increasing. If anything, the sun has weakened a little bit through these past 40 or 50 years. So we know very well that the sun has the capacity to push our climate around and cause it to be warmer and colder, and it's probably done that in the distant past. But in our lifetimes, the sun isn't changing much. If anything, it's getting a little bit weaker, a tiny amount weaker, and so it's not what's causing climate change. Volcanoes can also push the climate around, and this is Mount Etna in Sicily in Italy. People have done lots of work to measure emissions from volcanoes and how much CO2 comes out of these and other gases. And they know these all have effects, but nothing that explains what's happening right now. So I'll say a little bit about the Intergovernmental Panel on Climate Change in the next couple of slides, IPCC. You've probably all heard about this. I forgot to attribute it here on this slide, but this is from the most recent global report of the Intergovernmental Panel on Climate Change. And it's a bit complicated, this graph, but they try to put bars to explain all the different things that push our climate around and what's really behind things. So at the bottom here, total anthropogenic, this is the sum of all human activities that are pushing our climate around, and it's +1 watts per meter squared. This is how much extra energy is in the Earth system due to human activity. And you can see it going right up to the top. Most of that is from CO2 and the other greenhouse gases. And other things that matter for climate, like black carbon or contrails from airplanes and other influences. In the blue, the slight cooling influences, aerosols and clouds. Other things have some effects, but nothing is really as large as CO2 and greenhouse gases. That's what's pushing us around. At the very bottom, you see the slight changes in the sun. So you can kind of do these calculations for volcanoes and everything you can think of that pushes climate around, and you come to this very clear result that it's greenhouse gases that are causing the world to warm. And I like Laura's bathtub. It's much easier to understand than this picture. But this is showing, again, for the last century plus, the buildup of greenhouse gases. Most of this is fossil fuels and industry and us driving, using those fossil fuels. Land use change has some effect too. So this is deforestation and other things that change the land that have caused a little bit of the warming. And in the bottom, some of the CO2 is going in the land, some is going in the ocean, some is staying in the atmosphere, but it's clear the atmosphere can't keep up with all the CO2 we're putting in, and so the CO2 is building up. So this isn't, I've got a few more slides still to go, but this is a little interim summary of what's causing climate change. And there's lots more really intricate things happening, but at some level it's actually really simple. The way greenhouse gases work, the way they're understood, the way they're building up in the atmosphere, it would be really weird if the world wasn't warming. So it's almost like we don't need to be looking for other exotic things that are happening. And you can get confused online if you're reading too many dubious websites about this, but it's just pretty clear that greenhouse gases are building up and the world's warming, and that's kind of just the way it would be expected right now. Because of this, it's going to probably continue for as long as CO2 continues to build up and increase in the atmosphere. So we do control this to some extent. We have policies and aspirations and hopes of reducing and lowering greenhouse gas emissions and bringing the atmosphere to a more natural state. And our success with those kinds of policies will determine how much warmer the world gets. But these are very big changes because it's involving, our transportation systems, our energy systems. These are kind of generational changes that are needed, and they're needed globally to actually stabilize the climate, I would say. And the final point, other things can push the climate around, but they just don't explain what's happening right now. They haven't changed much in the last 50 years, while greenhouse gases have gone up a lot and temperature has gone up a lot, and everything that goes with that. And I'm going to go pretty quickly over this because I want to hear from Dave and I want to hear mostly your questions, but the world has been really aware of this, as I said, for many decades. And the first real United Nations summit that tried to talk about climate change was in 1992 in Rio in Brazil. So that's coming up to 30 years ago now. There's been so many meetings since then and probably not much progress. But in 92 in Rio, all the countries that were there signed on to this concern about greenhouse gases building up and interfering with our climate system. And they agreed in principle that we needed to act to help prevent global warming, to stabilize the climate. We've been through all sorts of different policies since then. Because of Rio, they, as part of that whole initiative, they first started to create the UN IPCC process, where it's actually pretty amazing. They've pulled together globally this massive community of international scientists. I'm sure Dave has been part of this. Most of my colleagues have been part of this at some point, either as an author, a reviewer. Some of your own research is fed into this process. It's all kind of voluntary within the UN. The climate scientists globally have come together to produce these big, huge reviews and synthesis reports. They came out every 6 or 7 years. When I was an undergraduate student in a 4th year class, the first IPCC report came out, and it was a pretty small volume. We were given this book over a weekend to read for class discussion, but you would never do that now, because now they're thousands of pages and they're massive literature reviews. And the next one will come out probably in 2022 with kind of the next update on the state of the climate. They talk about mitigation, they talk about adaptation, huge, crazy resources here that are available. So the science community is pretty galvanized. There's lots of information out there. A lot of it's gloomy and doomy. And so I'm trying not to spend too much time on that, but I think you've seen some of those world on fire sorts of reports. And every serious climatologist I know is really, truly worried about this right now, because we are not really taking much action yet, and we just continue to build up greenhouse gases, and the planet's going into some new regime that we don't totally understand where it's headed. So things like the Paris Climate Summit, which you probably heard of, it's already 5 years ago now, are now leaving the science and going towards the politicians and governments and policies. They've set out with lots of goals to try to help prevent dangerous human interference with the climate system, with a whole bunch of programs, and I would say that Fire with Fire is one such program that's part of Canada's response in terms of climate adaptation activities. And you can read lots about this if you're wanting to Google Paris Climate Agreement and what we've signed on to. 196 countries have adopted. It's in effect this year. It involves some support for developing countries to help them develop in more green and sustainable ways. The goal of this is to really try to stabilize the climate. And you'll see numbers like 2 degrees Celsius would be an objective to try to keep warming. We've already warmed by more than 1 degree Celsius. And so there's this goal of leveling off, trying not to warm more than 2 degrees Celsius, trying to keep it below 2 degrees Celsius. And part of that is this climate neutrality by 2050, just really trying to reduce emissions until we have carbon sinks able to keep up with carbon sources by the middle of the century. In fact, that's the only way to stabilize at 2 degrees Celsius. Sometimes you'll see the 1.5 degree mentioned, and that's something we could talk about for a while, but that was the original goal going into Paris, was try to develop policies that would keep warming to 1.5 degrees Celsius or less. And that's pretty much seen as best case aspirational. And I think the undertone is that we'll aim for that with a hope that we'll manage 2 degrees Celsius. It's kind of like setting an artificial deadline for yourself so that you have some stress and some urgency and try to get there. And then if it slips a little bit, then it's still better than no action. So the Paris Agreement and all the countries that have signed on to it, they are all agreeing that our goal is to try to limit warming to 1.5 to 2 degrees Celsius. And we're trying to develop national policies to get there. And I won't say too much more about that, but it's really important that the world gets there, because the sort of path we're on, the red line, the business as usual, takes us to a world that's 3, 4, 5 degrees warmer than present by the end of the century. The current national commitments are a bit better than that. They kind of go up the middle to a world that's 2 or 3 degrees warmer. The hope is that countries will get serious about this with renewable energy and other ways to reduce emissions, and we would follow more of the blue curve to keep the world to something closer to 1.5, 2 degrees Celsius. But this really requires a lot of global sort of action to get there, and I don't know. It's hard to be optimistic about that sometimes. Canada has some of the highest greenhouse gas emissions per capita in the world, so we definitely have some need to be leaders in this context, and really helping with developing technologies and solutions, and domestically within Canada, but then sharing these with the world in this effort. And I'll just skip through these, but just to say that there are lots of models and scenarios out there, and as you go from lower emissions in the top left, and in the next few decades down to end of century with the higher emissions, which is kind of the path we're on, we're heading again to this world on fire, this really red world with numbers that are crazy here. Like, I don't know if you can see it, but these darker reds are 9, 10, 11, 12 degrees Celsius warmer than what we're used to, warmer than the world we were born into. This is a completely different planet. This is like warmer than the Cretaceous when the dinosaurs were here. So this is what the climate models say. This is where we don't want to be and where we don't want our grandchildren to be. And there's associated scenarios for all these things: severe weather, precipitation, water resources, human health, biodiversity. All these things go together with how temperature and climate will change in the coming decades. And just to try to summarize things, I do think that for the most part, climate change isn't that complicated. We're seeing it happening more or less as predicted for many decades. now, and there's lots of details around that, what might happen to ocean circulation, and lots of kind of interesting science questions. But at some level, if we keep putting greenhouse gas in the atmosphere, the world's just going to keep warming up. And it's even worse than that. There are lots of feedbacks in the system. Like if you make the world warmer, there's more evaporation that Laura mentioned. There's more water vapor in the atmosphere, and that gives you even more of a greenhouse effect, because water vapor is a really good greenhouse gas. And lots of changes like less snow and ice make the world warmer. All sorts of feedbacks that take the nudge, the greenhouse gas nudge, and make the world even warmer. And we can expect some natural changes in the sun and other things that are part of Earth's cycles to happen on top of the human influence. Those might help us, but they might also make it worse. We don't really control those. So I think the big message here is human influence is causing this warming, and human and natural forcing is going to happen on top of this. Some years will be cooler and wetter, and some will be hotter and drier, but these natural forces are just kind of riding on top of this dominant human influence. Human impacts are now stronger than natural impacts on our climate. And I think because of that, we need to embrace climate adaptation. It's real. We're going for a bit of a ride, and we need to learn how to work with that. So climate adaptation is a really important thing to understand and accept, but also mitigation, because if we don't reduce emissions and stabilize the climate, then what can we adapt to? Because it's a constantly changing system, and it would sure be nice to know, what to plant and what to grow and how much water we're going to have in 2050 and 2080 and 2100. And we won't know as long as the climate keeps changing to some world that's beyond our experience. So we really need to stabilize it and adapt towards that. And I will stop there. Thank you, everyone.
Oh, I have to moderate now. Thank you, Shawn. That was great. I'm just looking to see if I can't see any questions, and I actually can't see any hands up. It doesn't mean there aren't hands up. Eli, do you see any hands up, or is anyone wanting to ask a question? Okay, if you want to ask a question, then click your thing that says raise hand. Or if you want to ask a question, put it in the chat for Shawn, or we can wait till after Dave's done too. I have a question for Shawn. Shawn, you live and breathe this every day. You're in Ottawa now working and seeing policy change. And how is COVID impacting the climate world from that perspective? What are you seeing?
There's lots of things we could talk about around that, but I think a lot of people are dismayed that, as much as COVID has disrupted life as normal and business as usual, and that has reduced emissions. I think emissions will be down this year by something they're estimating 30% or so, because we're traveling less aircraft. Maybe most of us here have been filling up in gas way less than normal because we're staying at home. Industry has slowed down and the economy has slowed down, and that's reducing emissions. But so it'll be a record amount of kind of year after year emissions reductions. Still not what we need by the Paris Agreement, but a big chunk of that. And I think some people think that should turn the climate change around. But of course it doesn't work that way, because climate change is due to like many decades of accumulation of greenhouse gases. So a 6-month reduction, 30% reduction in emissions isn't, we need 60 years of that, not 6 months of that. So it's some things that's helped right away, like air quality got way better in the past few months, but climate itself, it's not going to be affected very much by COVID. And if anything, the psychology of it's been hard for people, because whenever I get a chance, so thanks for this question, I try to say this is not what climate change action looks like. Like, people are struggling, a lot of people, and it's not been very fun, this whole COVID confinement. And I think there's this misconception out there that this is what climate change action looks like. We have to stay at home and not have holidays and trash the economy. And they're thinking, if this is what action on climate change looks like, I don't want to do that. Yeah. But it's not at all what to me what climate change action needs to look like. I think picture more people in electric cars instead of, gas-powered cars, and I picture more renewable energy instead of, our renewal and our interest in the coal industry. And so it looks like, having a good quality of life and having holidays and vacations and being out there and having an economy, but a different one than our, 19th and 20th century economies. And so that we need some communication around that. But I think we've learned from COVID that people can change and adapt more than people ever expected. And so the idea of shifting over to an electric vehicle fleet for the country doesn't seem as disruptive as maybe as it did a year ago.
Yeah, I like that. Okay, Eli, do you see any hands or questions? Okay, I hope it's working. I hope you guys just aren't sitting there burning to want to ask a question.
That's okay. There's a chance at the end for anyone. Do you want to introduce Laura? David, Laura, while you're here on the screen?
No, you.
Okay, I'm happy to give way to David Sauchyn, who I've known as an amazing colleague for many, many years. And David has been the director of the Prairie Adaptation Research Collaboration and some new and emerging climate change services within the country. He understands and knows more about regional climate impacts than maybe anybody I know. So I'm really happy to turn over and let David talk to us about what Alberta's past and future look like.
Yeah, maybe before David starts, I just want to say a couple things. So thank you, Shawn. That was great. You're educating one of our elders. She's staying for the webinar, so that's good.
Thank you so much. I feel very honored.
My turn? You can hear me okay?
Yep, we can hear you,
Yep.
Dave. Over to you.
Great, okay. Well, thanks, Shawn, for that kind introduction. And thanks for that overview. That was a great global overview and a introduction to what I have to say. I'm going to zoom in, so to speak, into Alberta specifically, starting with this slide of a scene in southwestern Alberta. This is actually property that I owned until last year. And spending 15 years in southwestern Alberta gave me a chance to meet local people, including members of the Kainai and Piikani First Nation, and that would include Elliott. So I'm going to speak, first of all, about how the climate is changing in Canada using the global context that Shawn presented. And the best and latest information about climate change in Canada is from this report that was produced and released by the federal government last year. If you look at on the cover of this report, it states that this is the first report to be released as part of a large series of reports. And the next report to be released will be an overview of climate change on the prairies. And I'm just completing that report with 15 co-authors, and we expect that report to be released this fall. It'll be the first of another, I think, 14 reports that will come out over the next year on these various regions and topics. So some of which I'm going to present today is contained in this report that you will see come out in the fall. And you'll know about it because there'll be a fair bit of media coverage of the release of our Prairies chapter. Looking at the climate of the prairies in particular, this is a map that shows how much the moisture varies from year to year across North America. And it's broken into two types of climates, the dry climate and the wet climate. But at both ends of the scale, whether it's a dark brown or a dark blue, it means that there's a large amount of variability from year to year. And you'll see that if you scan this map, in the center of North America, there's an area that's mostly in Alberta in which there's large variability from year to year. We tend to go from wet to dry from year to year. And that's because mostly North America is the second largest continent, and Alberta and Western Saskatchewan are near the center of this continent, where you can't get any further away from the oceans. And the ocean is the source of our water. So we tend to have dry years and wet years. And there's only one other place in the world that's like that, and that's Kazakhstan, because Kazakhstan is in the middle of the largest continent in the world, which is, of course, Asia. So not only does Alberta tend to have a large amount of variability from year to year, but it's known for its extreme weather. This is the 20 most costly weather events in Canadian history. First thing to note is if you look in the left column, they're all relatively recent. And if you look in the second column, most of them have been in Alberta. 16 of the top most costly weather events have occurred in Alberta and since the 1990s. And this doesn't include the hailstorm at Calgary this past June, which is costing more than $1 billion. So if we were to add this most recent weather event to this list, it would end up number 4. It would bump Toronto down to number 5 and represent the 4th most costly weather event. So we have a large amount of variability, we have extreme weather, and coming back to the report that I just introduced, these maps show that the largest rate of warming since 1948 has been in Western Canada, and especially in winter. So the darker the shade of red, the larger amount of warming. And the conclusion of this major report is that all of Canada is warming at twice the rate of the rest of the world. And that's the way the media, including the American media, reported the results of this study. But if you look at the scale across the bottom, Western Canada, and especially the Western Arctic, is actually warming at 3 times the rate of the rest of the world. And if you look only at winter, then Western Canada is warming at 4 to 5 times the rate of the rest of the world. So a large amount of the warming in our part of the world is in winter. Here is the lowest winter temperatures each year at Calgary back to 1886 and until last year. And there's a very strong upward trend in the low temperatures. And you can see we really haven't had a really cold winter until you go way back to 1969. So we can conclude that Alberta actually is not getting so much warmer, it's getting much less cold because so much of the warming is occurring in winter. And we'll look more closely at that winter of 1969 because I was there. In fact, I was given a certificate by the Edmonton Journal. I wasn't in Calgary, but I was up the road in Edmonton growing up, and all the school children in Edmonton were giving a certificate for having survived that winter. And there were 26 consecutive days in which the warmest it got was -21. That was the peak temperature. And of those 26 days, 21 of those days didn't get any warmer than -30. So it's just inconceivable today to imagine a winter in which there were 21 days below -30 out of 26 days. It just doesn't happen anymore. So we conclude, as a result of the warming of our winter climate, we're actually losing the advantage of our cold winter. Severe cold tends to suppress and keep a lot of undesirable plant and animal species. A lot of disease vectors and pathogens and invasive species simply can't survive that kind of cold that they are today. But the largest advantage of a cold winter is snow. This is Ray Glacier. This is a picture I took at the headwaters of the Elbow River when I was doing PhD research on this glacier. This was in 1982. I suspect the glacier is probably gone by now. It never was a very large glacier. And the loss of glacier ice, and the world authority on this is the person that just presented, Shawn Marshall. So all I'm going to say is, as a result of the research done by Shawn and his colleagues, we know that the glaciers and permanent snow is disappearing from the Rocky Mountains. And it is that snow and glacier ice that is the source of these rivers, the North Saskatchewan River at Edmonton and the Bow River at Calgary on the bottom. And when we take the information that people like Shawn provide, we can first of all examine this map produced by the University of Lethbridge. It shows that so much of the water that's produced in Alberta comes from the mountains, the blue area. And as we go out onto the plains, relatively little water is produced. In the red area, there's only less than 10 cubic meters per square kilometer. That's a very small amount of water that's being produced in this dry landscape. And so most of the water supply in Alberta is produced in the Rocky Mountains and is shed by those rivers. So here's another case where the Bow River, the headwaters of the Bow River, the Bow Glacier, if you compare a photograph taken in 1902 by the family of Henry Vaux and a picture taken in 2002 by Henry himself, you can see the extent of the loss of glacier ice from the Bow River and the headwaters, the Bow Glacier and the headwaters of the Bow River. So we can depict the impact of the loss of this glacier on the Bow River by comparing the monthly flows in blue presently, or in the recent past, to monthly flows we expect in the future. And you can see that the entire distribution of monthly water in the river is shifting to the left, where there's more water in winter, but less water in summer. And summer is the period in which there is the greatest demand for water. Similarly, if we look at the North Saskatchewan River at Edmonton, this is actually the recorded flows back to 1912. The river is rising in winter and it's falling in summer. And we are currently doing research for the city of Edmonton and for EPCOR Utility, which manages Edmonton's water supply. We've taken future climate and we've run hydrological models using the future climate. And you can compare in blue the past flow of the North Saskatchewan River to orange, which is the future flow. The past being a 60-year period in the past and a 60-year period in the future beginning in 2041. And once again, as we saw with the Bow River, that the hydrograph, the annual flow of the river, is shifting earlier in the year. And so that glacier melt and that melt of snow is passing through the river system now in winter and spring, leaving much less water available in the summertime. And we run this model not once, but 15 times. That's why there's 15 curves superimposed on one another. And by running it 15 times, we have more confidence in the results. That supply of water, that shifting of the water supply to winter and spring and away from summer, that really is just an indication of how our climate is changing. So here's a bunch of output from climate models for Western Canada, where we're comparing the climate of 2040 to 69, a future 30-year period, to the climate of the recent past between 1971 and 2000. And on the left is winter, and on the right is summer. Now, every time we run these climate models, we get a different future climate because we can't possibly know the future. But that even though there is a spread, it's like a shotgun, there's a spread of future climates, the results kind of converge on the conclusion that in winter, we can expect a much warmer climate and a wetter climate, because nearly all the models plot to the right of 0 along the horizontal axis, which means wetter. And all of the models plot above 0 on the vertical axis, meaning more and higher temperatures. Summer, on the other hand, if you look at the 0 mark on the horizontal axis, some of the models plot to the right and some to the left. So some of the models suggest we'll have more water, not a lot more, but more precipitation in summer. but about a third of models say we'll actually have less. And so we conclude that summers will be warmer, not nearly as warm as winter, and they probably will be drier. Because even if there is more precipitation, that precipitation will be lost to the higher temperatures and more evaporation in the summertime. So this is a basic as you can get, a climate projection for the future for Western Canada, including Alberta. But I want to now talk about why there is this range of future climates, because it's important that you understand why scientists can't tell people precisely what the future is going to be. And that's because there are various sources of uncertainty. Shawn already talked about how we have to make assumptions about the amount of greenhouse gases that the world will produce in the future. Those are those greenhouse gas scenarios in green. There are different climate models. Each country has one or more climate models that they developed. But even if you use the same climate model and the same greenhouse gas scenario for the future, you still get a different future climate. And that just represents the natural variability of our climate and those natural forcing factors that Shawn talked about. He talked about the sun, he talked about the circulation of the ocean, he talked about volcanoes. There's also the sea ice in the Arctic. And so these are the three basic sources of uncertainty that really prevent us from precisely forecasting the future climate of the world. And as we zoom down to the region, the amount of uncertainty becomes even greater. So we did a study working with a colleague, Dr. Elaine Barrow. We did a study recently of, well, let's look at the prairie provinces of Canada and say, okay, how much of our uncertainty is due to these three causes? And we did it for different variables. So because winter precipitation is so important, because of the snow is so important in our part of the world for producing runoff in our water supply, let's see how much of the variation and how much of the uncertainty is due to these three factors. Well, it turned out that it was mostly our knowledge of the natural variability. So you can see that the greenhouse gas scenarios become important, but they become important in the later part of this century, because we pretty much already know how much carbon dioxide and other gases have been produced in recent decades. Like Shawn said, it's actually not that complicated. The anthropogenic forcing is known. We know that we are producing too much carbon dioxide and we measure it. What we don't know is going into the future how much more we'll produce. And the climate models are pretty good. And so there is less uncertainty due to the climate models than just the knowledge of how well the models are able to replicate the natural variability. Now, you can find diagrams like this for the rest of the world, but what's unique about Alberta is because of the huge amount of variability in our climate, the orange area is much larger in Alberta than it is in other parts of the world. So not only do we have to understand the human forcing of the climate, and not only do we have to improve the climate models, but we have to understand just the natural forcing of our climate. So that's something that we've been doing in our lab for a long time, because every summer for the past 35 years, I've been taking students out into the forest, and in particular to the Rocky Mountains of Alberta. I'm afraid this might be the first summer in more than 35 years I haven't done that. But here's the Kootenay Plains of Western Alberta, where we collected some very old wood. These are limber pine trees. You can see some living trees, but also lots of dead wood. And by collecting living wood from living trees and by collecting the dead wood, we've been able to determine how much water has been in the soil in southern Alberta for the past 900 years. So this is the South Saskatchewan River Basin. And if it's a wet year, it was in blue. And if it's a dry year, it's in red. And the thing to note is, first of all, the huge amount of natural variability, but also there have been times when the river basin has been dry for decades. And this is recorded in the tree, so it actually happened, and it's going to happen again. And the worst possible scenario we can imagine for Alberta is for one of these long droughts to reoccur, but in a warmer climate. You can imagine what will happen to water supplies. And you can imagine what would happen of the risk of forest fire if there's a long period of drought occurring in a much warmer climate. Just got a couple slides left. Coming back from the past into the future, this is from the Canadian Regional Climate Model, the latest version, version 5. And we extracted information once again on winter precipitation. This is at Calgary, back to 1980 and up to the year 2100, the end of this century. We already discussed how we expect winter to become wetter. And that's what the model indicates. If we compare what the model says about 1980 and what the model says about 2100, we expect there to be rising winter precipitation. Now, this actually sounds pretty good because we live in a dry climate. And if there's more water, and if we can capture that water, it's probably a good thing. But the trajectory, the path we follow will not be that dashed line. Here's what the model tells us about how we're going to get from 1980 to 2100. It's going to be through a series of dry and wet years. And the important thing to note is the range from dry at the bottom to wet at the top is getting larger and larger. That's what we're looking at is the natural variability of our climate, amplified or exaggerated by a warmer climate. And this is one of the points that was on Shawn's concluding slide, that global warming is amplifying the regional climates. And so even though we might be able to take advantage of more water, the problem is we're going to have years that are way too wet than we're used to, and years that are still very, very dry. And therein lies one of the major challenges for Western Canada, is dealing with this amplified variability and the increasing range between the driest years and the wettest years. So I'm going to stop there. I'm going to put up a picture of southeastern Alberta, Cypress Hills, and use that as a backdrop if there's any questions.
Wow, thank you, Dave. I'm glad that you put this nice picture up because I'm feeling a little worried about our future.
I took this picture at sunrise and it was cold. My hands were stiff.
Beautiful. Okay.
But it's getting warmer.
We have a really quiet audience. Eli, do you see any questions? I don't see any questions in our little thing. Does anybody want to ask Dave something that's regional, like about your area, that you could probably address, specific to your lands?
Yeah, David, this is Elliot. Very interesting, scary stuff. But it's good to know what we're going to be expecting in the future. I'm doing some fish work in the next couple of months in Southwest Alberta. So I guess my question is, according to some of your graphs on the higher precipitation in the winter and less in the summer. So one of the species we're looking at is bull trout. And bull trout and cutthroat trout. They're two native trout in Alberta. We're looking at doing some recovery work with them. Cutthroat trout spawn in the spring, and bull trout spawn in the fall. So with cutthroat and more precipitation in the winter, it'll probably affect their spawning because there may be too much water. And then bull trout spawning in the fall, the water levels are going to be a lot lower and the glaciers are melting. So flow is going to be, it looks like, a lot less, and we're already seeing it now. So I guess my question is, any thoughts on how fish will be affected?
Well, good to see you again, Elliot, by the way. And I think that you more or less answered your own question, because you described how that we expect, and we've actually observed, that the water levels are rising in spring, but actually earlier in the spring. And that as the water passes through the system earlier in the year, by the time you get to the fall, that there's less water left in the hydrological system, and so water levels are dropping in the fall. And just based on what you told us about the spawning of cutthroat and bull trout, I found that very interesting, because I grew up fishing in the foothills in Alberta for those two species, mostly cutthroat and rainbow. Based on what you told us, that the obvious conclusion is that there's going to be more water than the cutthroat prefer in spring and less water than the bull trout prefer in fall. But I'm sure there are fisheries biologists who are studying this, and what they do is they take the kind of science that Shawn and I produce about the future climate, and they have their own models and their own observations about the fish, and they come to more detailed conclusions than you and I just reached. But it kind of makes sense what you already said. And the question is whether the fish can adapt, right?
Yeah, right.
Yeah, I mean, most species are fairly adaptable, but I don't know how adaptable fish are. And it also depends on how quickly the changes occur. And so we say that we want to slow the rate of global warming so we have a chance to adapt.
Yeah, no, thank you for that. And, you know, obviously trout prefer cold water. So there's no doubt streams are going to be warming up. Some of the work we're going to be doing is we're going to be installing data loggers in a lot of the tributaries of the Old Man and the Bow, just to start keeping track better of the water temperatures. So, you know, it's going to compound, you know, the whole problem for the fish. So I guess we'll see how resilient they are. Anyway, yeah, thank you, David.
That work would be very important, because, you know, some of us run models, or we take information from models, but they have to be confirmed, right? Somebody has to be out there taking measurements to confirm that what the models tell us are correct. So thanks for doing that.
I would just add to that, that was a good response, but I'm really glad you're doing that study too for the water temperatures, because it's a bit embarrassing. I feel like we don't have enough data on that, and from some of the conversations I've heard, that's one of the huge threats for the trout is the water temperature, especially in summer, late summer and fall, as we're losing that ice water that's flowing in, because you might be able to manage the water quantity, like hold some back through reservoir and things, but it's hard to manage the water temperature, and certainly in BC with some of the salmon spawning, the water temperature in the Fraser has been rising, and it looks like a looming problem. So it's great you're working on that.
So I just promoted Neil with Alberta Forestry. Well, you can say who you're with better. Neil, if you had a really good point that you just put in chat, and I'm wondering if you wanted to share that with the group, if you're able to.
Yeah, hi there, can you hear me?
Yeah, great. Oh, good, it worked. Good.
Great presentations. Thanks for sharing your information. I've just made a comment in the chat that the regional weather patterns that you are observing are exactly what we're experiencing in wildfire management, where we go from extremes. We used to manage typical wildfire seasons and knew how to prepare, and now we go from these extreme years that make the national and international news to like what we're experiencing this year in Alberta, which is basically nothing. And that used to be unheard of as well, where you'd have a fire season of just nothing. But it's problematic when you've got politicians with short memory spans, or that like to manage for the average trend line. There really isn't an average that we're managing anymore. We're managing extremes. And so what we're experiencing this year, if we start benchmarking this, it's maybe not what's going to be our experience next year. So anyways, I'm just seeing a direct parallel to some of the graphs you were showing and our experience in Alberta wildfire.
That's a great observation, and I appreciate it. I just made some notes because it's people like you in the field who are seeing these things that provide us with the evidence that the climate is changing in the direction that we anticipate. And the way you described it about how we're really managing for extremes, and we've seen this extreme weather over the past decade or 20 years, especially in Alberta. Scientists are a bit hesitant to attribute it to global warming for good reason. I mean, because it's a relatively small sample size. But there are studies that have been able to attribute greater severity of these events. They would have occurred anyway because they're droughts and floods and fires are natural. But they are occurring more frequently, but especially they are amplified. They're more severe, they're more intense. And there has been scientific research to show that the intensity of individual events has been increased by the fact that they're occurring in a warmer climate. I also appreciate the comment about how decision makers have such a short memory. And one conclusion that we've drawn from our treeing research, we have this 900-year record, is that there is a strong cycle in which there are decades that are relatively wet and decades which are relatively dry. Not every year, but there tends to be this clustering of wet years and dry years. And we've actually had in the past 10 to 20 years, and well, ever since, there was a severe drought in 1999 to 2004, but ever since then, we've had quite a few relatively wet years. And so a lot of decision makers have actually forgotten about how severe a drought can be, especially if it is prolonged. We've had some really dry months recently, but we haven't had entire years or back-to-back years in which there's been a deficit of water, and they tend to forget that these kind of events occur, and especially the consequences of back-to-back droughts.
Hey, Dave, I think you're still sharing your screen. Can you hit stop share?
Yeah, you bet.
Okay, cool.
And that comment feeds into the next question really well.
Why can't I do it?
Maybe where it says sharing screen, the bottom.
Yeah.
Eli, any ideas?
Okay, here we go.
Oh, there, perfect. You got it.
Okay, good.
So we have a question in from Marley. And Marley, do you want to go ahead and ask that? Unmute yourself.
Can everyone hear me okay?
Oh, yep, we can hear you now.
Awesome. Okay, well, first of all, Shawn and David, thank you both so much for those presentations. They were fantastic. I definitely learned a lot. So yeah, actually this is definitely complementary to what we were just talking about with drought. But David, you had pointed out at one point that in southern Alberta, there's a lack of water, but that's also a region in the province that is in high demand for water because of agriculture, so whether it's crop or livestock. So I'm wondering if you're aware of sort of what's being done to look ahead to the future as we have less water, but an increased demand for water, especially in that region.
Well, I expect that Shawn can speak to this as well, but the major policy response, this actually goes back to 2006, because as a result of the drought of 2001, 2002, in 2006, the Alberta government decided to close much of the South Saskatchewan River Basin, the southern tributaries. So as of 2006, with some exceptions, being First Nations, for example, with some exceptions, it hasn't been possible to obtain a license to extract water from the southern tributaries of the South Saskatchewan River, from the Oldman, the Bow, and the St. Mary's. And that was really, like I said, in response to a drought, but it's enabled the Alberta Energy and Parks to better manage the water supply in southern Alberta. Now, we'll just see when the next prolonged drought occurs, and when it occurs in a warmer climate, we'll see how adequate that policy is, because there is definitely a need for further adaptation and of the water management in southern Alberta. I know that the 13 irrigation districts have been doing a lot of work. In fact, they will tell you that they've really increased the efficiency of irrigation in southern Alberta through various, mostly technological and infrastructure innovations. So irrigation is relatively efficient in southern Alberta, which is important because irrigation, the agriculture accounts by far for the largest use of water in southern Alberta. Anybody want to add to that?
Just to build on that, I think it's a great question, because I don't think, to my knowledge, people really know what that next big drought will look like and how they're going to deal with it. And that's going to build on the last question too, because right now a lot of the planning is around the next big flood, because that will also happen, and because that was more recent, 2013, the big Calgary High River flood. I think there's the spring bank diversion, and whether that's going ahead or not, there's various actions to try to remediate against the next major flood event. And I do think people have forgotten a little bit what serious multi-year drought looks like. And there are plans back there, but I think the population continues to grow, the water use continues to go up, even though efficiencies are in there. City of Calgary is, if you go on their websites, they've gotten a lot better at per household water efficiencies, but that's counteracted a bit by population demand and industrial demand. So I do think that there's going to be a serious water shortage that might catch us a bit flat-footed, and it's hard to create water where there is none. So my suspicion is that there'll be some. It won't be until that happens that we get a lot of kind of reaction to it, and you'll hear discussions about whether to build in, means to hold that increased winter precipitation, to hold it back, to save it for those hot, dry summers, which will come at some point, whether it's 2020s or 2030s. And renewed conversation about interbasin water transfers, because Alberta's funny. There's so much water in the north and not much in the south, not enough in the south. And there's a real, lots of reasons and lots of resistance to any kind of interbasin water transfer like that. But I imagine once the next, serious 5-year drought cycle hits, we'll be talking about that again. So I don't know, Dave's closer to this than I am, but I kind of agree that we just haven't seen, since 1980s, maybe even a decadal scale drought. We haven't seen it with the modern sort of population and water demands that southern Alberta has, and I think it might hit us pretty hard.
Thank you, Shawn. Just cognizant of time, we're at 11:32. So we're gonna, if there's no other burning questions.
We have a question from Corbin, I believe.
Oh, okay. Yeah, let's go, Corbin. We can go 5 minutes in.
Sorry about that. It's not really a question. It's more of a comment, with me, I've been, working with the community for off and on for a number of years, for the last 20 some odd years. And as many of you realize, being Piikani, we're right downstream a couple hundred yards from the Old Man River Reservoir. And that, it has caused quite a bit of challenges over the last, couple of decades with the management of the water flows and whatnot. And I think, that's even evident this year where I'm down at the river, a couple times a week. I fish quite a bit. I'm strictly catch and release. It's just for entertainment. But, noticing the water flows, the levels, etc. It's kind of a little unnerving when I'm looking at the water flows right now and they're quite low in the river itself. But when I drive up to the reservoir, it's almost chock full. And it gets a little unnerving on a year, like maybe next year if it's a little bit more damp, or this year because it's a little more damp, they decide to hold back too much water, and then they have a forced release, early spring or whatnot, and that causes quite a bit of damage. So, and I know water management, reservoir management, water level management, is not an exact science, but yet, it's still, we often feel the brunt of anything that goes wrong. We're the ones who feel it first. As with water policies, water shortages, it was my understanding, that 50% of all the water flow that comes through, the Old Man through this South Saskatchewan River Basin, 50% of it must continue into the province of Saskatchewan, with their policies or legislation. So if we have a wet year, Saskatchewan's going to get plenty of water. If we don't have a wet year and a drought, Saskatchewan's going to get less water, Alberta's going to get less water. And it kind of puts, Piikani in a little bit of a conundrum is, we have a standing water license every year for 30,000 acre feet of water. And that's a fair bit of water. We can do a lot of projects and do a lot of work with that. But every few years, just to test the waters, somebody will bring it up to the province and say, okay, well, we're thinking about using our 30,000 acre feet this year. You can see a lot of nervous people in that room. And they say, okay, well, we're going to have to plan for that. Oh, you bet you're going to have to plan for that because, 30,000 acre feet of water, you can put easiest said is take 30,000 acres of land and put a foot of water on it, and that's basically what it is. So, even with us, it's been a challenge to even develop and work on our own license because, it's just, there's such a shortage of water right now. A lot of times when we try to develop or any opportunities or ideas, they quickly try to find ways that, okay, that's not a good idea. You shouldn't do that. At the end of the day, it's just, we just know they don't want us to use our 30,000 acre feet of water. Our rivers changed, our temperatures have changed, fish habitat has changed, even our beaver have changed. We no longer have beaver that build lodges. We have burrowing beavers. They burrow themselves into the banks. And that's where they put their homes. Why? Because that's the most stable when water levels shift so much. And so it's funny, we are almost coming to enough time, enough duration where we almost have a new species of beaver. They're called bank burrowers or whatever, you're going to have to come up with some scientific name for it, but that's one thing, one major change that we've noticed just because, beaver are so special to us. My brother and a lot of my family members, they are part of our societies, our spiritual societies, and they're having a heck of a time looking for supplies for harvesting and whatnot because the riverbank has changed. The entire river basin has changed. And it doesn't seem to be getting any better. It's getting worse. And it just seems that, with the Indigenous communities, we just seem to be lost in the rhetoric when it comes to, planning for water use and whatnot. We're seen as more of a nuisance than a willing participant. And it's been like that for a long, long time. I was a member of council 20 years ago, and we were negotiating our water license and our water deal. That's how long we've had our 30,000 acre feet of water. I remember a time when I was working for our community as our band administrator or CEO. And it was funny, the province of Alberta said, okay, well, we want, you have users of water, and we want them all a water meter so we know how much water they take out of the river. And I'm like, well, no, that's not going to happen. You want to see how much less water is coming out of the river? You put a monitor upstream, and then you put a monitor downstream, and you can figure that out yourself. You're not coming on the reserve with your monitors. And so, if they can be less willing to work with us, we can be less helpful to work with them. And so it's just been, for us, we've been dealing with the water issue for 20, 30 years, and it's most of the time with the province, it's been a negative, impact. So we do understand, we're very cognizant of the fact that there's climate change issues. And, we basically wanted to be a part of this for so long, but nobody really gives the Indigenous communities, the full seat at the table. It's always just a sidebar, a comment, a nuisance sometimes. Thank you.
Corbin, thank you so much for sharing that really local information that is, and concerns that really, with climate change coming, this stuff is even more concerning for Bourbagani and other communities who are having challenges. So thank you. And certainly as we're working through our adaptation work and the local area action plan, we'll be discussing that more too. Did you see any other questions, Eli? I didn't see any. So we're about 10 minutes over. So we'll end now, but if anybody has burning questions after, burning questions, go ahead and get in touch with me, Eli, Elliot, and certainly if you have questions for Dave or Shawn, I'm sure they'd be open to answering after. And hopefully this was a helpful day of an hour and a half of your time. And again, thank you to Elder Fox for opening this up in a meaningful and good way.
Our elder wants to say some comments before we quit. Go.
Thank you. Yes, I appreciate you allowing me to come on to say a few words. Just listening to all that has been said, even though I guess I'm somewhat aware of, the environmental issues that are happening. It's really, good to hear from specialists, and it's a concern, especially when it comes to water, because we have our irrigation canals, and I don't know how the reserve benefits from the canals, because it seems like all the water goes out. Thank you.
Thank you.
Yes, thank you.
Thank you. Okay, Shawn, David, thank you so much for your time today. I know you guys have a lot going on with school starting, sort of not, and Shawn with being there in Ottawa and all that's going on from the federal side. So thank you so much, both of you, for taking your time, and everybody else for joining us. This will be recorded, so there will be access to this. We have a sharing platform. It's a private Facebook group, and it will be posted on there at some point. So thanks again, and we'll see you all for our second webinar the last Wednesday of next month of October. Okay, all right, let's sign off. Goodbye.
August.
August.
All right.
Did I say November?
October.
Okay, thank you all. And thank you, Corbin and Elder Fox, for sharing. Really valuable.
Yeah, thank you, everyone.
Thanks, everybody.
Have a good day.
Bye.